All right, so we have rational functions, multiplying and dividing. So a rational function is an expression that can be written as p over q, where p and q are polynomials. So in other words, it's a fraction with a polynomial on the top and a polynomial on the bottom. So here's an example. Or even something like this could be a rational something like that could be a rational function. Or something like this. All right, so example number 1 says, find the domain of each rational function. So we're going to look at the denominator and see if there are any restrictions. So you can't have the denominator equal to 0. So for this first one, there's nothing in the denominator that will make it equal to 0. So your domain is actually all real numbers. So from negative infinity to positive infinity. Okay, now let's look at this next one. So what makes your denominator equal to 0? It would be x equals 1, so x cannot equal 1. The way you write your domain there is all real numbers except 1. Interval notation is going to be from negative infinity to 1, union 1 to infinity. Okay, so this next one, we want to go ahead and factor the denominator. So you're going to think of two numbers that multiply out to negative 15 and add up to negative 2. So that's going to be 5 and 3, and 5 will be negative. So x minus 5, x plus 3. So x cannot equal 5 and x cannot equal negative 3. That would be setting that equal to 0 and then setting that equal to 0. So your domain in this case, you could write it out as all real numbers except x equals 5, x equals negative 3. But the interval notation way, which you'll see in most classes, is this way. Okay, so that's the way you would write it. All right, next we're going to go ahead and simplify functions. So we're going to go ahead and go back to fractions. So let's just gonna give an example of 120 over, let's say, 120. So I know I could divide both of these by 10, right? So what we're going to do is we're just going to try to do, maybe the top will be 10 times 10, and the bottom will be 12 times 10. So you could simplify out the 10s, and then you get 10 over 12. And then on the top, you could do 5 times 2 and 6 times 2. And you could simplify those out. And finally, you get 5 over 6. So that's basically what we're going to be doing over here. We're going to try to factor the numerator and then factor the denominator and simplify. All right, so moving on to the first one. We're going to go ahead and you can't really simplify anything on the top, so I'll just leave it as 2x squared. But on the bottom, I could factor out a 2x squared. And then that gives me 5x minus 1. And then I know that the 2x squareds cancel out, and I'll have a 1 on the top. And so that's going to be 1 over 5x minus 1, and that would be our answer. All right, the bottom one, b, we're going to go ahead and factor the numerator and then factor the denominator. So I'm just going to go ahead and maybe do some side work over here. 9x squared plus 13x plus 4. All right, so maybe we'll do 3x and 3x, and then plus 4 plus 1, and see if that works. So that would give you 12x and then 3x. So when we add those together, we don't get 13. So I'm going to go ahead and erase that. And then I'm going to actually change this to 9x and 1x, and I think that will work. So this will be 4x, this will be 9x, and I get 13x. Okay, so that works. So the top of this I could rewrite to x plus 1 over 9x plus 4. And then the bottom, let's go ahead and do it down here. So 8x squared plus x minus 7. So we're going to go ahead and write this out. So this will be 7 and 1. And this, because it's going to have to cancel out with something on the top, I'm probably going to assume that it's going to be this one right here. So I'm going to assume maybe 1x and then 8x, and this one will be positive and negative, and see if that works. So multiply across 7x, 8x, and then I get 1x. Okay, so that did work. So you can use that little trick to be able to factor. So these cancel out, and what you have left is a 9x plus 4 over an 8x minus 7, and that would be your answer. Alright, so next we have simplify 2 plus x over x plus 2. So if you notice, they're the exact same thing on the top and the bottom. I'm just going to rewrite, remember, if I do 1 plus 2, that's the same thing as 2 plus 1. So I could switch the order when I'm adding. So I'm going to do x plus 2, x plus 2. And so these would cancel each other out, and you'd just be left with 1. Because anything over itself is just 1. Alright, so this next one, we're just going to go ahead and do the same thing. I'm going to switch the order. So negative x plus 2 over x minus 2. So if you notice, these are opposite signs, and then these are also opposite signs. So what I'm going to do is I'm going to factor out a negative out of the top, so it becomes x minus 2, and then x minus 2 on the bottom, and those will cancel each other out, and you'll get a negative 1. So you could always use this rule. So I'll give you another example. Let's say C. Let's say we have 3 minus x, and then on the bottom I have x minus 3. So again, negative x on the top, positive x on the bottom, positive 3 on the bottom, negative 3 on the bottom. Automatically, that's going to be negative 1. Alright, and lastly, we're going to simplify this rational expression here. So I'm going to go ahead and factor out a 2 out of the numerator. And then on the bottom, I'm going to go ahead and factor that. So negative 3, 2, so negative 3 and 1. That's going to multiply out to negative 3 and add up to negative 2. So that's going to become x minus 3, x plus 1. And then if you notice, this is actually difference of squares. So I could go ahead and rewrite that as 3 minus x, 3 plus x over x minus 3, x plus 1. So notice we just did this, right? C, 3 minus x, x minus 3, that's right here. So this whole thing is going to turn into negative 1. And so this becomes negative 2 over 3 plus x over x plus 1. And if you wanted to distribute that negative 2, you can. So negative 6 minus 2x over x plus 1. And then you're done.